This is section 2.6. Yesterday, or the beginning part of this section, we filled out this peach-colored note sheet that has all of the rules and stuff of these transformations. So when you are writing functions, you are looking at like things like y equals the absolute value of x plus 2, this guy down here, and you're trying to figure out what that 2 is doing, okay? These are going to be easier now that we've done this pink or this peach-colored sheet. Here are the rules again, if you want them listed out for you in this top box here. So let's talk about what each one of these would look like. Let's say we have the function y equals, let's do the square root of x this time. Okay, let's do the square root of x. Okay, so we're going to say that that is our beginning starting function. All right, and I'm just going to give you scenarios here, and we'll write out what that function will look like. So shifting up k units, let's say k is 7. So we're going to go up 7 units. What will that look like? Plus 7. Inside the square root or outside? Outside. So this will be the y equals the square root of x plus 7. Not inside, outside. Okay. Next, down. How many want to go down? 8. Down 8 units. What's that look like? Square root of x minus 8 on the outside. On the outside. Okay. Horizontal shift. How many want to go to the left? 4. 4 units to the left. Okay. What's that look like? Nope. Nope. Left 4.
Minus 4 or plus 4 in parentheses.
Plus 4 in the parentheses. Now, we are going to do this without any parentheses because the square root acts like our parentheses. So it is x plus 4. Everything's under the bar. Everything's under the square root. Okay? How many want to go to the right?
4.
Pick a different number.
7.
Pick a different number.
5.
5. A number we haven't used. 5. Y equals. If you're going 5 units to the right, it looks like x minus 5 in parentheses, but we don't have parentheses. We just have our square root bar, which goes all the way to here. Okay? Good? All right. Stretch vertically by a factor of a. What do you want to stretch it vertically by a factor of? 2. Okay? So y equals, that will look like, y equals, this is going to be hard. Maybe, not. Stretch vertically by a factor of 2. Multiply by 2, which is, looks like 2 times the square root of x. X squared is this. So not that. Square root of x. 2 square roots of x. Okay? Kind of. Vertically by a factor of a. Vertically compressed by a factor of a. What do you want to compress by? Now, hold on. Stretch versus compression. Your numbers depend on whether it's a stretch or a compression. What do your numbers have to be in order for it to be a stretch? That's not true. Everybody says fractions, but 3 over 2 is a fraction, and 3 over 2 is actually 1.5. That's making it bigger. How about a number less than 1? That's the rule. If your number is less than 1, it's going to be a compression. Numbers that are less than 1. Numbers that are bigger than 1 are stretches. Does that make sense? If it's 2 times as big, you're stretching it. If it's 3 times as big, 4 times as big, 5 times as big, you're stretching it. If it's half the size, less than 1, that's a compression. Half the size. Okay, a third of the size is a compression. All right, now, what if it's exactly 1?
Then that is stretch.
It's neither, because it's going to stay the same size. If I multiply it by 1, it's going to stay the same size as it was before. Okay, so there's the rule for stretch and compression. All right, back over here. What do you want to multiply by a factor of to make it a vertical compression?
1/4.
1/4. I like that. 1/4. Okay, so what will that look like?
2 times 1/4 or 4.
Nope, nope. No, on vertical compression and stretch, you don't flip it. Nope. It
1/4.
will stay 1/4 square root of x. 1/4 square root of x. Okay, now we're getting to the flippy part. Okay, now we're going to do the flippy part. Remember this part, this right here had a star by it, and this right here has a star by it because you use the opposite symbol when you're going left and right. Plus means left, minus means right. Down here you use the reciprocal. Okay, so compress horizontally by a factor of 1 over a. Okay, we want to compress it by a factor of something. What compression do you want?
9.
Compress.
1/9.
1/9. Okay, so we're going to compress by a factor of 1/9. Okay, hold on. Just wait. We're going to compress by a factor of 1/9. So what number is actually going to go inside of here? 9. And where does the 9 go? Inside. It's the square root of 9x. That's what you meant, right, Caleb? Yeah, okay. So 1/9 is your factor, but 9 is what goes on the inside. We're getting fuzzy here, sorry. Okay? Now, if we want to stretch it horizontally, okay, give me a number that would be a stretch. 4. Sure, we're going to stretch it by a factor of 4. What number goes on the inside then? 1/4 x. Okay, that's what he will look like. All right? And then a reflection across the x-axis means that you put the negative on the outside. Okay, so what will that look like?
Negative outside of the square root.
Yep, negative outside the square root x. Okay, what will the other one look like? Inside the square root of negative x. Do I have a new sheet? A new note sheet? Wait, didn't I just give you that? Oh, you want one of these? That? Okay, perfect. There you go. So those are the rules. That's with a different type of function. All right, example 1. Describe the transformation, or translation, I guess is what it's called. So, if I strip away all of the numbers away from this function, what type of function do we have? Y equals the absolute value of x. That absolute value is still there when we strip away the numbers. Okay, kind of like x squared. Do you remember what absolute value looked like yesterday when we went over those? It looks like a what? Somebody said it. A V. Okay, I'm going to do this one in black. So I'm going to write the original one in black and the other one I'll do in color. Okay, so the original one is a V, and when you do it, he goes up 1 over 1, up 1 over 1, up 1 over 1, and then this side he goes down 1 over 1, down 1 over 1, down 1 over 1. So he has a complete 45-degree angle this way and this way, which means like inside of here is a 90-degree angle. Okay, we're not going to mark that though, but whatever. Okay, so V, a complete perfect V. Now, the +2 is on the outside of the function, this guy right here. So how is that going to move my V? Up. He's starting at 2 instead of starting at 0, and he's up 1 over 1, up 1 over 1, up 1 over 1. Or down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. So that green one is my new one, and he is done. Describe the translation. Up 2. That's my describe the translation. You have shifted our function up 2. Yes, correct. That's easy. Woo. Now that you know the rules, right? Versus me giving you this function and you having to plot points. So much easier now that we know the rules, right? Oh, so much easier. Part B. If you strip away the numbers, what is left? Y equals x squared. And do we know what y equals x squared looks like? He looks like a parabola. Starting at 0, 0, he goes like this, and he goes like this. That's what the black one looks like. Okay? Now, what does the 7 do? Down 7. Down 7. He's starting here, and he's going this way, and he's going this way. That's not too bad. Oh, maybe. That's not too bad. That's not too bad. There's a delay on my screen. So that's what my new parabola will look like. Okay? Next one, describe and graph reflections. So if I strip away everything else, what's left over for this guy? Y equals x squared. That's what I'm starting with. Y equals x squared is the same thing as what it was in the last one. It is a parabola that looks like this. Okay? When the negative is in front of the x squared, not in parentheses, in front of the x squared, what's the rule? Reflected over the x-axis. So I'm just going to say over x-axis because I'm lazy. Reflected over the x-axis. So that looks like what? He's going to be down. Like this. That's what my new parabola looks like. Basically. That's what my new parabola is going to look like. Ah, oh, so nice. So nice. This is all we have to do. I think they have you do both. Yeah. They have you do both. Just graph the first one and then graph what it looks like afterwards. Yeah. You don't have to, no. I'll know which one it is because I know these. All right, now they're doing dilations. Dilations are what? What's a dilation? Stretch or compression? A dilation is like saying a stretch or compression. You've heard like the word dilate, like your eyes dilate, meaning your eyes get bigger or smaller. When you're having a baby, they talk about dilating. That's really unpleasant, but that's what happens when you have a baby. Because the baby's got to come out of somewhere, and that hole is not big enough, so you have to dilate. Okay, so that's what happens. That's what this is. You'll never forget the word dilate before again. So anyway, so dilation is a stretch or compression, larger or smaller. So y equals 4x. If I strip away those numbers, what am I left with? Y equals x. Y equals x, and what does he look like? A straight line in a 45-degree angle starting at 0, 0, up 1 over 1, up 1 over 1, up 1 over 1. Or down 1 over 1, down 1 over 1, down 1 over 1. That's what he looks like. Okay? So, what does the 4 do to it? Not up 4.
The slope. It's 4 over 1.
Okay? But what is that called? Stretch? Compression?
Stretch.
It's a stretch. What kind of stretch? A vertical stretch. Vertical stretch by a factor of 4. By a factor of 4. You don't use a reciprocal. So vertical stretch by 4. So we know what this looks like. You start at 0, 0, and you go instead. Not up 1 over 1, up 1 over 1. Yep, my slope is 4. Up 4 over 1, up 4 over 1. Or down 4 to the left 1. Down 4 to the left 1. And this is what my function looks like. That's what happens if you make him 4 times as tall. It makes him skinny, right? If you would take my height and weight, but make me taller, and I stay the same weight, I'm going to be a lot skinnier, right? Darn it, right? That's my excuse. So, like, if I'm the same weight and you make me taller, I could be like really skinny. That's my excuse is that I'm short, so I'm fat. Whatever. Right? Right? If you're short and you weigh the same amount as somebody who's tall, they look skinnier than you do. That's not fair. It's not fair. That's too sad. All right. Now, B. Don't laugh at me. B. What is here if you strip everything else away?
Y equals x.
Y equals x. Y equals x. Okay, they don't, for some reason, have a graph here, so we're going to make one. Here's my y equals x graph. Okay? Now, there are actually 2 things happening here. 2 things. What are the 2 things?
The compression. Negative.
Yes. So there are 2 things happening. First and foremost, and second and after that. Okay, there are 2 things happening. The 2, what does the 2 do to my function?
It moves it up or down. It makes it a... No.
It makes it a stretch. It's a vertical stretch again by 2, right? It's the same thing as what the 4 was.
So you go down 2 over
Just wait, just wait, just wait, just wait. Okay? So this one is a vertical stretch by 2, but then what's the negative do? Reflection over the x-axis. Okay? So basically, this first one, if I would go vertical stretch by 2, I'm going up 2 over 1, up 2 over 1, up 2 over 1, and it looks like this, right? Something like that. I'm not going to draw him really thick yet because that's not the right one. Then I reflect him over the x-axis and he looks like that. So he's the opposite way, so he's actually going to go this way. Or in other words, that is down 1 over, or down 2 over 1, down 2 over 1, like my slope says. Down 2 over 1, down 2 over 1. Yeah? Does that make sense?
No, because they're using it as a stretch.
What?
Why is it a stretch?
It's a stretch because it's taller than what just x was. Right? Just like the 4 was. Look at the 4. The 4 was a stretch, right? Because instead of being y equals x squared, up 1 over 1, you're going up 4 over 1, up 4 over 1. Here you're going up 2 over 1, up 2 over 1. Oh, I getcha. You're using like the less than 1, like -2 is less than 1. Okay? Don't look at the negative. It's just 2. You're separating 2 from the negative. You actually can't have a negative number as a stretch or compression. You're only looking at that value as a positive. I see what you're saying. Yes, -2 is less 1. So maybe our rules on the front side of this sheet should say this. A stretch is a number that's greater than 1. That's fine. But a compression, x has to be greater than 0, but less than 1. Does that make sense? Okay. Your compression, your number has to be greater than 0 and less than 1. So we're only looking at the 2. We're not looking at the negative. Does that make it? Okay, I forgot to say that. That's better. Okay, thank you for identifying that for me. Okay, and the last one. Example 4, the graph of the quadratic function f of x is shown in the grid. I don't know who that is. If the graph of f of x is translated 5 units to the right, 5 units to the right, and 3 units down to create a new graph, which function would best represent this new graph? Okay, 5 units to the right and 3 units, and this is not right here. Because there's no 5s and 3s there. Hold on, there's a typo here somewhere. No, it's a typo in the book too. What are they doing? Oh, I see. Okay, never mind. They're saying if we take this guy right here, which function best represents this new graph? Yeah, we're good. This new function right here, or this parabola, if we take him and shift him 5 units to the right and 3 units down, what will he become? That's what they want. So if you notice, these are going by 2s. So if we go 5 units to the right, it's going over 1, 2, 3, 4, 5. He will now be here. And 3 units down is 1, 2, 3. He will now be here, and he'll look like this. You see that? If I shift that vertex of the parabola, which is at -1, 2, if I shift him 5 units to the right, he will now be at 4, -1. 5 units to the right from -1 is at 4, and 3 units down from 2 is at -1. Does that make sense? Okay? Now, if we look at this in terms of just y equals x squared, what does the 4, -1 look like? Okay? Y equals x squared is this function like this. So what have we done to the original y equals x squared to get this guy? You've reflected it across the x-axis, right? So we need a negative out in front. Okay? But then we've shifted it, after we reflect it, we've shifted it how many to the right? From 0, 0, though, we've only shifted it 4. From the original, we've only shifted it 4 units. Do you see that? What's 4 units to the right look like? X minus 4, because it's the opposite sign. X minus 4, okay? And then we've gone, what, 1 unit down from that? Right, from the original, 1 unit down looks like -1. So which one is that? B. B. Yeah, understand kind of? This one was kind of weird because you weren't starting with the original function of y equals x squared. You were starting with something different, okay? And then they want us to compare and show you what that looks like, okay? Good? Questions? Yes, you can. All right. Everybody say bye, Liddell.
Bye, Liddell.